Before we get into how construction equipment works today, with air-conditioned cabs, joystick controls, and GPS-guided blades, we need to talk about what it was actually like to operate heavy machinery 100 years ago. In 1925, on a muddy construction site in rural Kentucky, a bulldozer operator climbed onto a massive crawler tractor at 5 in the morning. The sun was barely up over the dirt road they were building. There was no cab on the machine, no windshield, no seatbelt. The heavy steel crawler tractor weighed 20,500 pounds, and the blade hanging off the front was held in place by a steel cable wrapped around a winch drum. That cable was the only thing between control and catastrophe. If it snapped under load, and steel cables on early construction equipment snapped regularly, the blade would slam into the ground, and the operator had about half a second to react before the tractor pitched forward. He would work that machine for 10 to 12 hours straight. In summer, the engine heat radiating up through the steel platform pushed temperatures well past 120 degrees at the operator's position. In winter, there was nothing between him and the wind, except whatever coat he could afford. His pay was about $8 to $11 for the day, which comes out to roughly $140 in today's money. And if he died on the job, which happened at a rate 15 to 21 times higher than modern construction, his family might receive a small workers' compensation payment. Or they might receive nothing at all, depending on which state they lived in and how cooperative the contractor felt. This was a harsh reality for many families. This was the reality of operating construction equipment before hydraulics, and it lasted for decades. To understand what these men went through, we need to look at the machines they actually operated. These were not the smooth, responsive, computer-assisted machines we know today. Every one of them ran on cables, clutches, gears, and brute force. The bulldozer as we know it was born on December 18, 1923, when James Cummings and J. Earl McLeod filed their patent for a blade attachment on a crawler tractor. The concept was straightforward. Take one of the heavy steel tracked tractors already working on American construction sites and bolt a massive steel blade to the front. LaPlante Choate of Cedar Rapids, Iowa built the first commercially produced bulldozer that same year, and it went straight to work on the Dixie Highway project in Kentucky, pushing dirt and clearing stumps on the rough American roads of the early 1920s. The blade was controlled entirely by cable and winch. An operator could raise the blade by engaging the winch drum to wind the cable. Lowering it relied purely on gravity. There was no hydraulic downforce to push the blade into the ground. No ability to angle the blade left or right. No tilt adjustment. The operator had the cable winch and gravity. That was it. If the cable jammed or the winch clutch slipped, the blade did whatever it wanted. The crawler tractors themselves were equally unforgiving. The heavy machines that dominated the 1920s American construction sites weighed anywhere from 10,000 to 20,000 pounds. The largest models produced about 60 horsepower from massive gasoline engines with 4 cylinders and over 400 cubic inches of displacement, turning at just 850 revolutions per minute. You could hear these machines rumbling across a dirt construction site from half a mile away. Both steering clutches were operated by heavy hand tillers with separate brakes on foot pedals. Changing gears while the tracks were moving was forbidden. The entire drivetrain had to be completely stopped first. Get that wrong on a steep slope or a muddy embankment, and you could strip the gears or stall the machine with 20,000 pounds of steel sliding backward down the hill. There was no cab of any kind on these early bulldozers. The operator sat on an open steel platform with a thin metal seat, fully exposed to rain, dust, engine exhaust, and flying debris. On a typical 1920s construction site, the bulldozer operator was the most visible and the most vulnerable man on the job. Rollover protection structures did not exist. ROPS were not mandated until OSHA required them in the 1970s, more than 50 years after these tracked machines first churned across American dirt. If a bulldozer tipped over while working a hillside or slid into a muddy ditch, the operator was pinned under tons of steel and iron with nothing between him and the ground. The danger of cable-controlled blades went beyond simple mechanical failure. When a bulldozer pushed into a buried stump, a boulder, or an underground obstruction, the sudden resistance could snap the cable instantly. The broken end whipped back toward the operator at lethal speed. Steel cable under tension stores enormous energy, and a half-inch cable breaking under several thousand pounds of load releases that energy in a fraction of a second. Operators who survived cable snaps often carried the scars for life. Those who did not survive were recorded in company logs as equipment accidents, if they were recorded at all. Even routine operation took a physical toll that modern heavy equipment operators would find hard to imagine. Every control lever on these early bulldozers was long, heavy, and completely unassisted by any power mechanism. Pure muscle against mechanical resistance, hour after hour, for the entire working day on a dusty, noisy construction site. Equipment manufacturers eventually introduced what they called feather touch booster clutches by the late 1920s, but only because they realized they were losing money late in the shift as their operators gradually tired. Before those improvements arrived, the only solution to operator fatigue was a replacement operator, and on most remote road construction and earth-moving job sites, there was no replacement available. An exhausted operator did not just slow down production. He became a danger to himself and everyone working near him. Missed clutch engagements, slow reactions to terrain changes, and sloppy cable management all contributed to the accident rate. And when something went wrong on a hillside or near a trench edge, there was nothing to save the operator. The machine had no cab, no rollover bar, and no seatbelt. The machine tipped, and the man went with it. If bulldozer work was brutal, scraper work was worse. The earliest earth scrapers date back to 1883, when a blacksmith in Fresno, California designed a simple steel bowl that could be dragged behind a team of horses or mules across open farmland. In its original form, a man walked behind the heavy steel scraper bowl, holding wooden handles to control the cutting edge as the horses pulled it through the dirt. When the bowl was full of earth, the operator lifted the handles to raise the cutting edge, and the team of horses dragged the loaded bowl across the field to the dump site. The physical effort of controlling a loaded earth scraper behind a team of draft horses was extraordinary. Operators fought the handles through every bump, rock, and tree root in the ground. By the 1920s, scrapers were being pulled by crawler tractors instead of horses. This was faster, but it created entirely new dangers. A tractor-pulled scraper moved at 4 to 6 miles per hour over rough terrain, with the operator riding on the scraper frame behind the tractor. There was no suspension. Every rut and rock sent shocks straight through the steel frame into the operator's spine. The vibration alone caused chronic back injuries that left men unable to work by their 40s. No suspension made the riding brutal. The cable controls on motorized scrapers were even more dangerous than on bulldozers. The bowl was raised and lowered by cables running from the tractor's power takeoff through a series of pulleys. These cables operated under extreme tension, sometimes thousands of pounds of force. When a cable snapped, and records from the era confirm this happened regularly, it whipped back with enough energy to kill a man instantly. The steel cable could cut through flesh and bone like a blade. Operators and ground crew working near scraper cables knew that a sudden metallic ping, the sound of a cable strand starting to fray, meant they had seconds to get clear. Extreme tension was a constant threat. Loading a scraper required precise coordination between the tractor operator and the scraper operator. The scraper man had to drop the bowl at exactly the right moment as the tractor powered forward into the cut. Too early, and the bowl dug in too deep, stalling the tractor. Too late, and the pass was wasted. On large earth-moving projects, push tractors worked behind the scrapers to provide additional force during loading. This meant an operator sitting on a scraper had a 20,000-pound bulldozer pushing directly into his back at full throttle. If anything went wrong with the timing or the cable controls, the scraper operator was trapped between two massive machines with nowhere to go. The dump cycle was equally hazardous. When a loaded scraper reached the fill area, the operator released the bowl cable to dump the load. A fully loaded scraper bowl could weigh several tons, and releasing that weight changed the machine's center of gravity instantly. On uneven terrain or soft fill, the sudden weight shift could tip the scraper sideways. The operator, perched on an open steel frame with no restraint of any kind, had no chance of staying with the machine if it rolled. There was no restraint to protect them. Between the cable snap risk, the push loading danger, the constant spinal punishment from riding without suspension, and the dump cycle instability, scraper work had one of the highest injury rates of any equipment operation in the 1920s. But the work paid well by the standards of the day, and there was never a shortage of men willing to do it. The alternative for most of them was common labor at half the pay, swinging a pick and shovel for 50 cents an hour instead of operating a machine for $1 or more. The highway boom of the 1920s created enormous demand for another machine that rarely gets the attention it deserves: the motor grader. The Federal Aid Highway Act of 1921 committed the United States government to building a national network of paved roads. Before this, most American roads outside of cities were dirt or gravel. Suddenly, the country needed thousands of miles of graded, leveled road surfaces, and it needed them fast. This is where grader operators came in. Early graders were horse-drawn steel frames with an angled blade slung underneath. A team of 4 to 6 horses or mules pulled the grader while the operator rode on top, turning hand wheels to adjust the blade angle, height, and tilt. Each adjustment required dozens of turns of a heavy hand crank against the resistance of the blade, dragging through compacted soil. The physical effort was so demanding that operators rotated every few hours to prevent complete exhaustion. The transition to motor graders began in the mid-1920s. By the early 1930s, the first truly integrated motor graders were rolling off American assembly lines, combining the engine, frame, and blade into a single machine. But earlier models from various manufacturers were already mechanizing the grading process on highway construction projects across the country. These early motor graders put the operator on an elevated steel platform above the long angled blade, surrounded by multiple hand wheels and heavy levers controlling blade position. The steering worked through the rear wheels via a massive hand-cranked steering wheel that required significant upper body strength to turn, especially when the blade was cutting through heavy clay soil on a muddy rural road. Grader operators worked the edges of highways under construction, shaping ditches and shoulders while construction traffic moved past them at close range. There were no traffic control measures, no flaggers, no cones, no barriers. A grader operator working a road shoulder had trucks, other equipment, and sometimes civilian vehicles passing within feet of his position. The machine itself offered zero protection, with no cab, no rollover structure, and the operator sitting high and exposed above the blade. The blade itself presented its own dangers. A motor grader blade is typically 12 to 14 feet long and weighs several hundred pounds. On early machines, all blade adjustments were purely mechanical. Hand wheels controlled blade angle, height, tilt, and side shift. Each adjustment required multiple turns of a heavy crank against the full resistance of the blade, dragging through comicat earth. An operator making continuous blade adjustments while simultaneously steering and watching for traffic was performing a physically exhausting multitasking exercise that lasted the entire shift. Grader work also meant constant exposure to oncoming material. When the blade hit a rock buried in the road surface, The impact transmitted directly through the steel frame to the operator. Larger rocks could deflect off the blade and fly upward toward the operator's position. Without a windshield or any protective screen, the operator's face and eyes were completely exposed. Safety glasses were virtually unknown on construction sites in the 1920s. Eye injuries from flying debris were so common they were rarely even reported as incidents. The heat was another factor that grader operators faced differently than bulldozer or scraper men. A grader operator sat high above the road surface in direct sun, with engine heat rising from below and radiant heat reflecting off the freshly graded road surface. There was no shade, no canopy, no water supply on the machine. Heat stroke and heat exhaustion were regular occurrences on summer grading crews, and the response was almost always the same. The affected man was pulled off the machine, someone else climbed on, and the work continued. Road construction in the 1920s was extraordinarily dangerous for another reason that had nothing to do with the machines. Dust. Unpaved road construction generated massive clouds of fine particulate matter that operators breathed all day, every day, for years. There were no dust masks. Silicosis, the scarring of lung tissue from inhaling fine silica particulae, was already a known killer by the 1920s. But awareness did not translate into protection. At the Hawks Nest Tunnel Project in West Virginia, which ran from 1930 to 1931, workers drilling through pure silica rock without any dust suppression died at catastrophic rates. Official company figures admitted 109 deaths. Congressional hearings documented 476. Independent researchers estimated the true toll at 764 dead, most of them African American migrant workers, earning 25 cents per hour. The men who operated all of these machines shared certain things in common, regardless of whether they ran a bulldozer, a scraper, or a grader. Men. They were almost exclusively men between 25 and 50 years old. Younger than that, and they lacked the mechanical knowledge to operate the equipment. Older than that, and their bodies often could not handle the physical demands. Most had an elementary education, typically through 6th to 8th grade. The workforce was heavily immigrant. Immigrant workers dominated many crews. Irish workers dominated the trade unions and tunnel work. Italian laborers were prevalent in general construction. Eastern European workers from Poland, Czechoslovakia, and Hungary filled out the crews. Scandinavian immigrants, particularly Swedes and Norwegians, were heavily represented in the upper Midwest and Pacific Northwest, logging and road building operations. The Mohawk ironworkers from the Kanawake Reservation near Montreal had already established their legendary reputation in high steel work on bridges and skyscrapers across the Northeast. There were no formal training programs of any kind. No schools, no certifications, no licensing requirements. A man entered the trade as a common laborer, digging trenches and moving material by hand. If he showed mechanical aptitude, he might advance to oiler, the man responsible for greasing and maintaining the equipment before and after each shift. From oiler, the next step was machine helper or fireman on steam-powered equipment, responsible for maintaining boiler pressure and water levels. Only after years of watching, learning, and proving himself would a man finally get the chance to operate. Training was learned on the job. The International Union of Operating Engineers, originally founded as the International Union of Steam Engineers on December 7, 1896, absorbed the International Brotherhood of Steam Shovel and Dredgemen in 1927 and dropped the word steam from its name in 1928. This reflected the industry's gradual transition from steam to internal combustion, but the union's primary function in the 1920s was establishing wage scales and work rules, not safety standards. Safety was simply not considered part of the equation. Union priorities were about pay and work rules. Union-scale wages for equipment operators in the mid-1920s ran approximately $1 to $1.37 per hour. That translated to $8 to $11 per day and $44 to $60 per week. Adjusted for inflation, an operator's annual earnings of $1,500 to $2,500 come out to roughly $23,000 to $39,000 in today's money. These men were solidly skilled trades middle class, but the work was ruthlessly seasonal. Rain, snow, and frozen ground shut down projects for months at a time. Few operators achieved 52 weeks of employment in any given year. Wages defined livelihoods, but not job security. Workers' compensation existed in most states by the 1920s. Wisconsin passed the first comprehensive law in 1911, and by 1921, 44 of 48 states had enacted some form of coverage. But benefits were meager. They were capped at low maximums, limited in duration, and in the states without laws, injured workers or their widows had to sue. Even where laws existed, contractors routinely misclassified deaths to avoid paying claims. The men who built Hoover Dam know this story well. Hoover Dam, constructed between 1931 and 1936, recorded 96 official industrial fatalities. The real number was higher. 42 additional deaths were classified as pneumonia, which families alleged were actually carbon monoxide poisoning from gasoline engines running inside the diversion tunnels. Temperatures in those tunnels reached 130 to 140 degrees Fahrenheit in summer. Workers earned 50 cents to $1.25 per hour. The high scalers, men who dangled from ropes on the canyon walls, removing loose rock with jackhammers and dynamite, had perhaps the most dangerous job in American construction history. The overall death rate tells the full story. Construction in the 1920s killed approximately 150 to 200 workers per 100,000 per year. Today, that number is 9.6. That means construction was roughly 15 to 21 times more deadly a century ago than it is right now. For iron workers specifically, the rate was even more extreme. The International Association of Bridge and Structural Iron Workers recorded 109 deaths out of 10,928 members in 1911 and 1912. That translates to approximately 1,000 deaths per 100,000 workers per year, which was twice the death rate of American soldiers deployed in 2010. There was no OSHA. The Occupational Safety and Health Administration did not exist until December 29, 1970. Before that date, construction across America was essentially self-regulated. The first commercial hard hat was invented in 1919, made of steamed canvas, glue, and black paint, inspired by the steel doughboy helmets American soldiers wore in the trenches of World War I. But wearing a hard hat on a construction site was entirely optional for over a decade. The first major project to mandate hard hats for all workers was the massive Hoover Dam construction site in the Nevada desert in 1931. The first official hard hat area in America was the Golden Gate Bridge construction project in San Francisco in 1933, where the chief engineer made it a fireable offense to work without one on the towering steel bridge structure above the bay. For the men of the 1920s, none of this protection existed. They worked without hard hats, without safety glasses, without hearing protection against engine noise estimated at 90 to 110 decibels during operation, without fall harnesses, without dust masks, and without rollover protection on any piece of equipment they operated. The prevailing attitude, as one safety executive later summarized, was that it was not considered legitimate work if the job was completely safe. The era of pure cable and muscle control began to end in the 1940s, when hydraulic systems started replacing cables on construction equipment. The transformation was gradual, but it changed everything about what it meant to operate a machine. Hydraulic blade control on bulldozers became standard through the 1940s and the early 1950s. Suddenly, an operator could raise, lower, angle, and tilt a blade with fingertip pressure on a lever instead of wrestling with cable winches. The blade responded instantly in both directions. Gravity was no longer the only down force. Cables were no longer the weak link. The winch drums that had required constant maintenance became obsolete. Hydraulic steering replaced the old hand tillers and clutch brake steering systems. Enclosed cabs began appearing on heavy construction equipment, first as aftermarket additions and then as factory options. By the late 1950s, a bulldozer operator on a modern construction site sat in an enclosed cab with hydraulic controls, a padded seat, and at least some protection from weather and debris. The contrast with a 1920s crawler tractor, where the operator sat on bare steel in the open air, fighting heavy cable levers all day long, was staggering. ROPS were developed through the 1960s after decades of rollover fatalities finally forced the industry to act. OSHA mandated rollover protection on virtually all earth-moving equipment in the 1970s. Seatbelts followed. Sound-suppressed cabs brought noise levels down from over 100 decibels to 70 or 80 inside the cab. Air conditioning and pressurized cabs eliminated the heat and dust exposure that had shortened operators' lives for generations. The men who operated cable-controlled bulldozers, scrapers, and graders in the 1920s did not live to see most of these improvements. Average male life expectancy in 1920 was just 54 years. For construction workers, with their exposure to dust, noise, vibration, extreme temperatures, and a workplace death rate that would shut down any modern job site instantly, the number was almost certainly lower. They built the roads we drive on, the foundations of the cities we live in, and the infrastructure that made modern America possible. They did it with cable controls, mechanical clutches, and nothing between themselves and machines that could kill them in a heartbeat. Every lever they pulled, every cable they trusted, every shift they survived was a bet against the odds in an industry that treated human lives as an acceptable cost of doing business. The machines got better. The protections got stronger. The death rate dropped by over 90%. But that progress was paid for by the operators who came first, whose names were often never recorded, and whose deaths were frequently concealed. If you want to see the machines these men actually operated, we covered the cable-era bulldozers and scrapers in detail in our Before Hydraulics series. Those videos are on screen now. And if this is the kind of construction history you want to see more of, subscribe to Construction Legends. We cover the machines, the disasters, and the people who built the modern world with fire, steel, and nerve.